infrastructure, I thought, well, DAFNI kind of comes from infrastructure research, sorry. So DAFNI kind of comes from a recognition that, like other parts, other areas, research into infrastructure, i.e. the sort of built human environment, is now very affected by data and computing. So John Armitt came to our launch event a year ago and from the National Infrastructure Commission and said data is now important UK infrastructure as concrete or steel. So DAFNI has come from the recognition that there, this is a big area that's growing, and with it comes a whole bunch of technical challenges to what we would do to actually expand the growth of data and computing for infrastructure research. So I won't go through this in detail, but we've got issues of scaling up. There's more data, more high resolution. We have big issues about data diversity and heterogeneity, and how to bring that all together into integrated platforms that can work together. How we can work on different models, different computer programs that do data analytics or simulation, and in different domains, the water, energy, land use, digital or transport, or waste sectors and infrastructure, but also the areas they connect to, like the natural environment and the human environment. And also at different scales, ranging from an individual item of equipment right through up to a whole country or region or country. So lots of challenges in this move from exploring infrastructure and human built systems to computing. Lots of challenges that come with it need to be addressed. This is one of where DAFNI has come from. So DAFNI is the data analytics facility for national infrastructure, and the idea is to provide a computing platform to improve decision making for national infrastructure, particularly research into national infrastructure, and how. So give us a platform to support research into planning, investment, and design and operation of infrastructure. And this is an £8 million investment that's happened over the last 4 years under the UK CRIC, that's UK Collaboratorium for Research in Infrastructure and Cities, and it's been put together by a consortium of 12 universities, led by the University of Oxford, and we were engaged at STFC Rutherford Laboratory as a delivery host and delivery partner. So you may not know us, but we are a interdisciplinary research laboratory that specialises, well, we're in part of the Research Council family that specialises in delivering infrastructure, including large facilities and infrastructure to UK research programmes. So this is an appropriate thing to us to do. We have a large computing capability at Rutherford. So what DAFNI is intended to provide, well, a hybrid high-performance computing platform, a secure repository for heterogeneous national infrastructure data and models, so we can bring these data and models into one place, have a collaborative platform for research and development of those models of infrastructure assets, so we can execute those models on the platform with the data we have, and then as Robert mentioned, a place which gives a legacy, places where we can make these data models available for long-term accessibility. So rather than when research projects end, we would hope that a platform like DAFNI would be able to maintain them for longer periods of time and make them available across research community. So to go into some of those features a little more detail, we have a high throughput computing hardware platform. It's fairly powerful. It's not vast, but it's fairly powerful. So we have a 27 server node cluster with 792 CPUs, with a fair amount of RAM and an additional GPU capacity, and with up to 2 petabytes of storage of various forms. Some of the the storage is rapid access for maintaining large models and large databases in memory, or rapid access. Others are more archival storage. And that's in our machine room at RAL. It's been set up as a Kubernetes cluster, which I'll go into, which gives us certain features which we'll explain later. And this gives us that rather more computing power to boost up applications, make them faster, scale them up. And then on top of that hardware platform, we have been building a number of components. Firstly, a data storage platform based on an object storage system, and then 5 particular components or component areas we've been working on: a database or data repository for maintaining the collection of data which we are building. A modeling service which allows us to upload and run models and integrate models together in workflows. A cloud environment which provides some remote access capability. A visualization suite to give it additional particular functions which support additional visualization. This is very much a work in progress at the moment. And then a security service which gives us some assurance that we're not releasing data to people that aren't entitled to it. So it's quite a licensing thing around it. So we're trying to be open as possible, but as secure as necessary. So I'll just go into the main features that we've been working on most intensely are the database and the modeling service, and we'll give some demos of that in a little while. So I thought I would mention those a little bit more. So we see DAFNI as being an information infrastructure, a data hub. So we've been working a lot on a data repository where we can share data, integrate data, and provide sort of data curation for long-term storage and access. So we've got a trusted, secure store to hold and access the data. We should be able to import and link some other data sources. And we've been working on a metadata framework, which is a strong basis for doing metadata for the data collection, but which we can also extend it into other areas. And it's an area of active development is looking at how we can extend the metadata and the ontological framework in which DAFNI sits. And it kind of sits in with the notion of the fair data principles that we should be as widely available as possible, as open as we can, but as secure as we need to be. So we can publish and make data available for reuse, but provide the necessary restrictions for secure or personal data. I'm going to have a demo about that later. And the other major area is the NIM service, the modeling service. So I mentioned we were using Kubernetes platform. So this allows us to be quite independent when we are when we're concerned with the different models that are produced by different research groups. Models are containerized using Docker. That means that we can be independent of, or roughly independent of their code-based operating system, so we can have them upload and run on the system without having to worry about library compatibilities and things, because everything gets bundled up. And that makes it easier to share models, and particularly we can then run them on our cluster. The Kubernetes provides an orchestration of those containers on the nodes, which allows us to scale up, access data into NID, and access visualizations. And also then we can also chain workflows together, have them one outputs, one feeding the inputs to the other, so we can chain them together, and we can start to do the model coupling, which is an important part of the framework which we want to take forward in OpenCLIM. So it gives us that potential to couple across different sectors and different scales. And those screenshots are from the demos, which we'll again show a bit more later. So just to final section is where we've got to. Well, it's been a 4-year program. This phase 1, as I'm now calling it, the phase 1 of the program, a 4-year development, of which we're coming into the last straight. We're still building got some final components we're still working on, we're still building, but we would tend to have a production platform by the end of March. So we're doing a very intensive development at the moment to try and get all that ready. So things are moving. It is quite a moving target at the moment. There's been a hardware investment on this into universities at the same time. So the university partners are also gaining some hardware to go into their local institutes, which we will hopefully work with the core DAFNI system. We're doing a lot of pilots works, which I'll mention more in a moment, and we've also set up a number of champions, which are individuals and universities that we've given some funds to do some pilot work with us. We're doing a lot of outreach, including lots of webinars like this one, and we're developing our sustainability plan for the next phase. I mean, you know, we are we're working with our funders and partners to get the sustainability plan in place, and there's lots of things going on. I can't really talk about them any at the moment, but you know, the sustainability beyond April 2021 is obviously a thing we are very much working on. That phase 2 may well have more capability for digital twins and things like machine learning, expanding the data infrastructure, and the better, you know, and expanding on the framework for integrating tools. So just go a couple of the pilots we've been doing. So this is just a couple of sort of special screenshots of some interfaces that we built as specials for particular pilots. So the left-hand side one is a railway transport model looking at the effect of putting a new station in and what happens to the demand profile where passengers come from to come to a new station on a railway line. I think this is Helston, I think it's down in Cornwall, the map. And the one on the right is the Simming model for the University of Leeds, which is looking at the how demographics change and the movement of people change with households, jobs, and the economic activity in an area. And this is particularly looking at the Oxford-Cambridge arc, which is an area place which we're actually working with. That sort of Oxford-Cambridge ARC project is also looking at the NISMOD tool. So we have a talk about this specifically later. So we're working with the ITRC consortium, particularly in Oxford, but also elsewhere, including in Newcastle. Particularly there's a system called NISMOD. So NISMOD is a systems model, combines several different models together. So it's sort of and we're moving this on to DAFNI. It's still a work in progress, but because it's quite a complicated thing to do, but it is happening in the background, and it kind of gives us a major sort of use case or pilot on this sort of data integration issue, model integration issue. The final use case I will mention is on urban observatories. So these are sensor nets around cities, and we are been working with particular ones of these, particularly in Sheffield and Newcastle, where we did some hackathons, and so seeing what we can do by providing a central computing hub for those services. So this is comparing Sheffield and Newcastle on their traffic movements in the morning. And this kind of naturally leads us on to our future ideas of how we would support digital twins. So DAFNI and OpenCLIM, just the final couple of words. So why we're in OpenCLIM? Well, we feel that as Robert mentioned, the features that DAFNI supports is makes it an appropriate platform for OpenCLIM. We've got this HTC platform which allows us to scale up models in a common information infrastructure, and we have a framework, particularly with NISMOD, to scale and couple models together to give us the model integration framework, and we have that legacy for publishing and maintaining models into the future in a place where researchers can share and reuse data, the models. So what's the work in progress and what issues coming up? Well, we've been doing a model survey, which I know some of you have been involved with. So we've got a initial group of models that which we know we need to support on. I think we have I think it's talking CityCat, isn't it, later? So we're looking at how we can bring these onto DAFNI and how we can support them. And access the appropriate data sets, and then it's the kind of the open questions about how we take that forward, how we provide the usability of the models. DAFNI provides typically a sort of halfway house between a sort of highly technical interface and what you might call a point and click user face, so if that's suitable, bespoke, or should we be looking at more bespoke user interfaces? I think that which will require quite a lot more work. And then open up the issues around model integration. NISMOD is our starting point from this as a pilot project on DAFNI, and we'd want to gather requirements for data and model integration framework. I think that's all I had to say. So